Hey everyone, welcome to another video, and today we're working on the logic and reasoning questions from the Green Book. So first question, river crossing. 4 people, A, B, C, D, they need to get across a river. There's only one way to get across the river, which is an old bridge, and that bridge holds at most 2 people at a time. So they also need to cross the bridge with a torch, and they only have 1 torch. So each pair of people can walk at the speed of the slower person, and they all need to get across the river to the other side as quickly as possible. So these 4 people, A takes 10 minutes, B takes 5 minutes, C takes 2 minutes, and D takes 1 minute. So we need to cross the bridge 2 people at a time, and one of them has to have a torch, or the person crossing the river has to have at least 1 torch. So let's call this the left side and this the right side. So we need to get all 4 people across to the right side, and at the start, all of A, B, C, and D are on the left side. So right off the bat, we can see that A and B are the bottlenecks. They're the slowest people. They walk at a speed of 10 and 5. And because they're bottlenecks, we want to have them cross the river together. Because otherwise, that would waste a lot of time having 10 and 5 go separately, because that would just be 15 minutes right off the bat. And also, if we want A and B, the bottlenecks, to go together, we can't have them cross immediately. Because what happens if they cross immediately? Then they go across, so it's A, B on this side. They have the torch on this side. Then one of them has to go back. We don't want any of A and B to be going back and forth because that takes a lot of time. They're the slowest people. So we want A and B to cross together, but we also don't want them to cross at the beginning. So that means we have to have C and D cross together at the beginning. So let's have C and D cross at the start. That takes 2 minutes for C and D to start. So C and D are on the other side now. We can remove them from the left side. So now someone has to go back. Let's have the faster person go back. So let's try having D go back. I wrote C, so let's have D go back. That takes 1 minute. So now we have, let's keep the D here. So now we have A, B, and D, and C is on the right side. So what should happen now? We should have A and B go together as we wanted, and they have the torch. So we can have A and B go together now. They take A, B, they take 10 minutes because they're going at the speed of the slower person, which is A. So now after this, we have D on this side and A, B, and C on the right side. So after that, we need to have someone pick up D. We can have A, B, or C pick up D, but A and B are slower. So we should have C go over. So C should return to the left side. That takes 2 minutes to pick up D. And then C and D can cross to the right side. Sorry, I should write all the people. So A, B in here, C, D here. And C, D go across so that A, B, C, D are all on the right side. So C, D takes the speed of the slower person, which is C, so that's 2. So in total, that takes 10 plus 5 plus 2. So this takes 17 minutes for them to go across. So note that in this solution, it doesn't actually matter if we have C or D go back first. So for example, let's use a different color. If we had C go back, this takes 2 time. That means C is on the left side. So we're going to have D pick up C. So D, this takes 1 minute. And then C, D go back together, which takes 2 minutes. So this gives us the same answer. It just swaps the order of C and D going back and gives us the same answer. So this is the optimal solution because we have A and B go together. If A and B go separately, that's 15 minutes right off the bat, and we can't have C or D cross and then go back to get them. So, and then the only way we can have A, B go together is if they go in the middle. Because we can't have A, B go in the start, since if they go at the start, someone has to go back to get C or D, and that would take at least 15 minutes just for that to happen. If we have A, B go at the end, then they have to be the only 2 people on the left side, and that's impossible because we need someone from the right side to give them a torch. So the only way is to have A, B go in the middle, and this is the solution to do that. So moving on to the next question, the birthday problem. So you and your colleagues know that your boss's birthday is one of the following 10 days. So March 4, March 5, March 8, let's just write that down. So March 4, 5, 8. It could also be June 4 or 7, September 1 or 5, and December 1, 2, or 8. So A told you only the month of his birthday. So me, I know the month. And told your colleague C the day. So C knows the day. I know the month, C knows the day. So after hearing that, you first said, I don't know A's birthday, and C doesn't know it either. After hearing what you said, C replied, I didn't know A's birthday, but now I know it. And now I smiled and said, now I know it too. So now after looking at the 10 days and hearing your comments, your assistant wrote down A's birthday without asking any questions. So what did the assistant write? So this is a question of people going back and forth, saying things that seemingly mean nothing, but actually carry a lot of information because we only have a select number of days to pick from. So in the beginning, let's use a highlighter. So first off, I said I don't know A's birthday. That's obvious because I only know the month, so it can be any of these months, and any of these months have more than one day, so I don't know A's birthday. But I also said C doesn't know it either. So I know conclusively that C doesn't know the birthday of my boss. What does C know? C knows the day of the month of the birthday. So if supposedly it was June 7th and C was given the date 7, then C would conclusively know the day of my boss's birthday. But I know that C doesn't know it, which means it's not June 7th. How do I know it's not June 7th? Well, I only know the month, so I know it's not June. So I can cross off all the possible days in June. So another unique number in here is 2. So if C was given 2, C would know that the boss's birthday is December 2nd. But I know that C doesn't know it, and I know that because I know the month is not December. So we can eliminate all of these possible dates in December, not December 1st, 2nd, or 8th. So after hearing what you said, C replied, I didn't know A's birthday, but now I know it. So C didn't know before, but after what I said, C now knows the birthday. So how come C knows the birthday? C knows the date. So C knows that it's either 4, 5, 8. So what are the possibilities? It's 4, sorry, I missed the 1 here. 1, 4, 5, or 8. So if it's 5, there's 2 possibilities. It could be September 5th or March 5th, in which case C doesn't know the birthday. But C says he does know the birthday now after what I said. So we can conclude that it is not any of these 5th. So it's not March 5th or September 5th. So we can eliminate 5 from the list, and we're left with 1, 4, and 8. So now you smiled and said, now I know it too. So what do I know? Remember, I know the month. So if the month was March, there's 2 possible days in March, the March 4th or March 8th. So I wouldn't conclusively know which day it is. But I conclusively know, which means it's in September. I know it's in September because September only has 1 day, and I know the birthday from C's comments, which indicates that it's in September, because I know the day, and September is the only way I conclusively know. So we can conclude that my assistant wrote down A's birthday, and that birthday is going to be September 1st. So that's this question. Although like my comments and C's comments, to some people might seem like it's not carrying any information, but for the people who know that these are the only possible days, each comment can eliminate a lot of options. And the fact that me and C are both keeping track of which days are eliminated, we can quickly deduce which day the boss's birthday is actually on. So there's a lot of similar questions out there to this question. This is just a very well-crafted question in that every statement can eliminate a bunch of options, so we quickly are left with only one choice, September 1st. So moving on to the next question, card game. So a casino offers a card game using a normal deck of 52 cards. The rule is that on your turn, we turn over 2 cards at a time. So suppose we have a black card. Let's say we have a black card and we have a red card. Then if both are black, they go to the dealer's pile. So both are black, that goes to the dealer. If both are red, they go to my pile. So red, they go to me. So if one black or one red, that means it's discarded. So black, red, this is going to be discarded. So the process is repeated until you go through all of the 52 cards. So if you have more cards in your pile, you win $100. Otherwise, including ties, you get nothing. So we need to have more cards in our pile than the dealer's pile for us to win. And the casino allows you to negotiate the price you want to pay to play the game. How much would you be willing to play this game? So in this question here, we're using the entire deck. So starting off, there's 26 black cards and 26 red cards. So if two are black, the dealer basically gets a point. If two are red, I get a point. And if it's one black, one red, no one gets a point and we move on. So that's a lot of cards, so we should consider a simpler case. So for example, we have a case where there's 2 blacks and 2 reds. So when there's 2 blacks and 2 reds, there's 2 possibilities. One is that there's 2 blacks in my pile, 2 reds in the dealer's pile, and nothing gets discarded. So the discard pile is empty. So another possibility is that we draw 1 black and 1 red to start off. So the discard pile has 1 red. It has 1 black and 1 red. So there's going to be 1 black and 1 red left. So the discard pile is going to get that black and red, in which case both my pile and the dealer's pile is going to be empty. So notice that in both of these situations, the dealer wins because we have a tie. There's the equal number of cards in my pile as the dealer's pile. So in both of these is a loss. So let's try a similar approach, but let's try it with 3 cards in each pile to get a better sense of what goes on. So there's 3 blacks and 3 reds. So what are the possibilities? So suppose we start off with 2 blacks. That means the dealer gets 2 blacks. That means there's 1 black and 1 red left. So we could either have the 2 reds be drawn first or the 1 black, 1 red to be drawn first. In either case, it's going to be black, black, red, red, and 1 black, 1 red in the discard pile. So that's one situation. Another one is that no pairs of blacks or reds are drawn. So my pile is empty, the dealer's pile is empty, and everything goes into the discard pile. So black, 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 red, red, red. So again, in both of these situations, I lose because it's a tie, and in ties, the dealer wins the game. There's an equal number in my pile and in the dealer's pile. So quickly we can see a pattern here. Why is it always tying? So an observation we can make is that the discard pile, what I drew in green here, this pile here, this pile always has an equal number of black cards and red cards. So reds equals to blacks. This is because whenever there's a discard, we're discarding 1 black card and 1 red card at a time. So the discard pile always grows by 1 red card and 1 black card at a time, so the blacks always equal the reds in the discard pile. So remember that in this question, we start off with the same number of blacks and the same number of reds, so 26 in both cases. So because the discard pile always has the same number of black cards and red cards, and we're starting off with the same number of black cards and red cards, that means my pile, which only has red cards, and the dealer's pile, which only has black cards, will also always have the same number. So hopefully that made sense, because first of all, we're starting off with 26 blacks and 26 reds. So suppose there's X cards in the discard pile, so the blacks will decrease by X, and if we have X black cards in the discard pile, that means we also have X red cards in the discard pile. So that means I have 26 minus X in my pile, and the dealer has 26 minus X in their pile. And no matter what X is, so no matter what number of cards get discarded, our piles will always have the same number of cards in them. And because in this game, we are losing if there's a tie, the dealer wins for ties, then we shouldn't be paying anything to play the game. Because no matter what happens, no matter how many cards get discarded, my pile always has the same number of cards as the dealer's pile, which means we're losing. So to play a game that's guaranteed to be losing, we should be willing to pay $0 to play that, even if the outcome is $100 for winning, because that's impossible to win. So that's it for this video. Hope that made sense and hope you're able to learn something. Thank you guys so much for watching, and I'll see you in the next video.